Okay. Yeah, we're down a few people this week because some kids we're traveling this week with their families, so small class today, but that's fine. What's this one? Yep. Okay. Today we're going to talk about different opportunities in computer science outside of what we've been doing and how to pursue these opportunities if they sound interesting to you. And we don't want HP support assistant, so let's get rid of that. Okay. Oh, actually, also I need to. Also, does anyone want these Jolly Ranchers? Want a couple? That's those ends. Oh. Let's see. Come on. Okay. So first, let's go over exactly what we've been doing so far. And that is we've been programming in Java, right? We're writing Java programs. So we've been using the Java programming language to write different programs we've been doing. We did tic-tac-toe. We did some different games. We did some stuff for the Fibonacci numbers. And yeah, it's been good. And we've been writing in an IDE called Eclipse. So what IDE stands for is Integrated Development Environment. And if you recall from the very first class we had here, we said we're using Eclipse. We don't actually need to use Eclipse, right? We could use Notepad or Microsoft Word or really any program that allows you to write into a text file. But you probably can see now why this is not nearly as good as Eclipse. So when you're starting to write code in Notepad or one of these really simple text editors, you lose the ability to have syntax highlighting or method suggestions or stuff like error highlighting. So you know when you see those red X's in Eclipse over on the left-hand side and you've got the words that are underlined in red? Well, that's really cool because that gives you instant feedback on where all your errors are and what you need to do to fix them. But if you're writing in Notepad, you have to compile and read the error messages and try to figure out what's going wrong. So Eclipse saves you a ton of time, in short, basically. So hopefully you can appreciate that now. And we've been writing these programs to run on desktop and laptop computers. So kind of like a traditional computing environment that we all have. We were all using our laptops. You guys probably all use desktop computers at school or at home. And this is great. So there we go. And desktop computers and laptop computers are really important. And they get a lot of work done, and they're really powerful. But yeah, one other thing is that, just for your knowledge, Java is considered cross-platform. And this is something that's a little weird to understand, but basically it means if you write Java on a Mac or on Windows or on a Linux machine, you can run it on any three of those platforms. It doesn't matter. It doesn't mean that if you write something on a Mac, you can only run on a Mac. Or if you write something on a Windows machine, you can only run on a Windows machine, which is a really good property of Java because I'm sure you've sometimes tried to download a program online and accidentally downloaded the wrong version, like the Mac version if you're trying to run a Windows program, which is really frustrating and kind of clunky, and Java eliminates all that, which is really good. So just for your knowledge. But yeah, so as I said, desktop and laptops are really important, and they are like the workhorses of the computing world. They're really powerful and really fast compared to our other devices, but this doesn't mean we shouldn't be trying to take advantage of these newer technologies. So these newer technologies, the first one obviously being the smartphone, which is kind of changing the world and changing the way that we do computing and changing the applications that we can write. Another technology, this isn't necessarily a new technology, but it's something that we haven't really touched on in class, is just different networks. So like a typical Wi-Fi network or just a data network, or being able to leverage those to be able to connect to different computers and to different people and to get our data out to the world at large. And then we've got our iPads and our tablets, which we haven't really talked about too much, but these are really similar to our smartphones and our touchscreen mobile devices, and also just other things like cameras or other hardware that we want to bring to life and give some ability to complete tasks for us. So how do we do this? Well, I'm going to kind of go through what it takes to get software on all these different types of devices, and if this is something that interests you, then we'll go through how you can do it and how you can learn. So first up, smartphones. So let's do a little history lesson with smartphones really quickly. So the first smartphone was invented in 1971 by this guy, Paris Givak. I don't even know how to say his last name, and it looked like this. So this is kind of a lenient definition of a smartphone, obviously, but this was the first guy to combine a computer and a telephone. And as you can probably guess, it didn't do too many things. I think it basically just was able to log data based on a call that you made, which is pretty cool, but it's nowhere near what we have the ability to do today. But just so you know, this is where it all started, 1971. And then through the 90s and early 2000s, we had PDAs and BlackBerries. And these were really popular in the business world, and they allowed people to access their email remotely and even do some rudimentary internet browsing on the go, which was really cool. And it was revolutionary at the time. And then in 2007, this is probably the conclusion you guys were all waiting for, Apple released the first iPhone. This was the first device that we can kind of see as being similar to a smartphone that we have today. And it's pretty crazy because this was in 2007. That was 7 years ago. It wasn't like this was a really long time ago or anything. It was 7 years ago, and in between the period of 2007 and now, the world has changed a ton because of this innovation here, the smartphone. Which I think is pretty crazy. That was only 7 years ago. It seems like we've had smartphones forever, but maybe I'm being naive. And then, of course, Android came out a year later and kind of introduced some competition to the market. And actually now the market looks pretty similar to as it did back then, where Apple and Android kind of share the market, and there aren't too many other major competitors. So I'm not sure if that's how it will continue to be in the future, but it hasn't changed much since the beginning in that regard. So with the advent of the smartphone, became this massive new opportunity for software. So there was, where ideas didn't really make sense for a laptop and a desktop computer, they started to make sense. We started having the ability to create apps that were specific to your location or things that you were doing, like such as a navigation program like a Google Maps, which allows you to direct you from point A to point B. Now, this is something you can't really accomplish with the laptop that doesn't have a data connection, or a desktop that just sits on your desk. And now you have the ability to write apps like Shazam, where you have a computer on your side, and if you want to know what a song is, you can just pull it up anywhere you are. So this is a huge new opportunity for software. And basically, although there are millions and millions of apps already written in those past 7 years, there's growing potential for new ideas. As these devices become faster and more capable, we can start doing more and more complex things. So there's tons of potential here. And as I just said, basically, if you're interested in writing mobile apps, you want to either focus on Android or iPhone or both, unless you're being explicitly hired to write something for like a Windows phone or like any other third-party mobile operating system. But I would think you'd want to either learn Android or iPhone. And so let's just walk through both of these really quickly and the specifics of them. So I know a lot of people are kind of confused about what exactly Android is, and I think a big reason for this is because Motorola came out with a phone called the Droid, which people get really confused and think it's synonymous with Android, which it really isn't. It's just a new phone, or not a new phone, but a different phone model. What Android is it's Google's mobile operating system. So it's just an operating system that Google created specifically to run on mobile devices, and they made it available for different phone manufacturers to use. So these are the people who have taken advantage of this are like Samsung, HTC, Motorola, and probably a bunch of other ones that we don't have here in the US, but those are like the big ones basically. So it's a big platform, and there's a lot of different phones for it basically. And here's some good news. So Android apps are written in Java. So that's awesome, because that's what we've been learning. And that's actually a small reason as why we were learning Java in the first place, is because there's this huge new application for the language, which is Android applications. It's using applications too many times, but I think you get the idea. And another really cool thing about Android is you can get started with the Android SDK, which stands for Software Development Kit, and the ADT, which I actually don't even know what it stands for, but that's the Eclipse plugin, for free. So you can get set up to do Android development totally free, and you can use Eclipse, which is really nice, because that's what we've been using so far, and that's what you guys are probably getting comfortable with, which is really awesome. And another really cool thing about Android is that publishing apps is easy. And it's really easy to put an app that you've written on your own phone, and to put an app that you've written on your friend's phone for testing. And once you want to get it out to the masses, it's really easy to put it on the Google Play Store, which is Android's app store basically. And that's really awesome. And you'll see why it's really awesome when we start going over the iPhone development process right now. So iPhone is obviously Apple's smartphone. Everyone knows that, I think. And it runs an operating system called iOS, which is Apple's mobile operating system. So just to clear up a little bit of confusion, so iOS is analogous to Android, and iPhone would be analogous to like Samsung Galaxy S5 or something like that. So iPhone is the phone, iOS is the operating system, and here we go. So iPhone apps are written in Objective-C. So where Android apps are written in Java, iPhone apps are written in this language called Objective-C. And Objective-C is a little weird. So the syntax is kind of strange. If you looked at an Objective-C program with the Java background you have right now, you'd probably be really confused. But it's actually not that different at its core. So once you learn this new kind of weird syntax that it's got going on, it's got a lot of the same concepts. So it's still an object-oriented programming language, just like Java. It still has variables, it still has methods, it still has classes and objects, and if statements and for loops and while loops and arrays and basically all the same stuff we've been going over here. And as you'll find out, most programming languages have all these things. It's just the way you create and use these things, like the syntax basically, might be a little bit different language to language. And with Objective-C, it happens to be a lot different, which is okay, but there's definitely going to be a learning curve there for you when you're trying to learn Objective-C. And so where Android apps can be written in Eclipse, which is the program we've been using to write code in, Apple's got this program called Xcode. So that's the IDE, the Integrated Development Environment for iPhone apps. And Xcode is pretty cool. It's one of the really cool things about it is it's got a really mature and fleshed out interface designer. So basically it allows you to just graphically drag around buttons and labels and like text input areas and stuff like that, and images or whatever you want to make your apps look really nice really quickly and easily, which is actually really nice. And there's not really a good Android answer for that. It's more of like a code-based interface design on that side of things. So that's something that's really cool about writing for Apple. And otherwise, it's pretty similar to Eclipse with the syntax highlighting, the method suggestions, and all that good stuff. So that's the good stuff, and here's the bad stuff. So Apple makes you pay $99 a year to develop for iOS. And it also basically requires that you develop on a Apple computer. And these are two things that really bug the hell out of me. I think it's really annoying. Because basically what they're trying to do is make it so that only serious developers try to develop for iPhone. And I think this is detrimental because it scares away people who are just trying to learn, for learning's sake. And maybe people that aren't trying to just make money right off the bat, but want to just learn so they have the skill of being able to write iPhone apps. So I think this is a mistake on Apple's part. But I'm sure they have their reasons. It's just kind of annoying for us as developers. And here's another thing that's kind of annoying is, well, it's good and bad, but the apps are subject to a review process before you are able to publish them. So it's harder than it is for Android to get your stuff out on the market, which is probably good because then malicious apps that might introduce a virus or something like that to your device are screened out. But it's kind of annoying because now you've got this gap between when you want to release your app and when it actually gets released. But I think they're actually making this part less intense, or so I hear. Okay, so that's the overview. Let's just do a quick comparison side by side. So Android, one of the advantages of Android for you guys is that it's in Java, language that we've been learning. You can write it in Eclipse, a program we've been using to code. So the learning curve is going to be less severe. And that's not to say that there's no learning at all. Like there is some things that are specific to writing to Android that you have to learn. But there's all kinds of tutorials and a really helpful community out there to help you along when you're learning. And it's pretty simple actually. So if you can write Java like we've been writing Java, then you should have not too big of a problem learning the Android side of things. So that's a good thing. Another really good thing is developing is free. You can learn for free. You can learn on your own time. You don't have to stress about paying any fees or having the right equipment because you can develop on any machine you want, which is really nice. Publishing is easy, as we went over. It's really easy to test and easy to publish, which is nice. And another thing we haven't really talked about is that the majority of smartphones in the world right now are Android phones. I think it's like 60 or 65% of phones or something like that, which is good because it means you have more potential users to use an app that you create. And some of the cons, okay, this is something that is actually pretty annoying. So there's tens, maybe even hundreds or thousands of phones that run Android. And these phones have all sorts of different qualities. So some of them are really small, some of them are really big, some of them have like a physical keyboard, some of them are slower or faster than others. So these are all things you have to consider when you're writing your program. You have to say, okay, is this going to look okay on a really small screen? Is this going to look okay on a really big screen? Is this going to be able to run on these slow phones? And it's just something that's makes the development process a little bit more difficult. But typically what you're going to do here is explicitly test your app on some of the more popular phones and then kind of just hope and pray that your stuff works on the less popular phones because there's literally no way you can, as an independent developer, get access to hundreds of different phone models to try them all out. It's just too expensive. But something you have to consider, and this is something that's kind of annoying about Android. And another thing that's a little annoying from a monetary sense is that typically you get less money per download for an Android app as a developer. And this is because basically Android's monetizing strategy is not as mature as Apple's. The advertising is not quite as good, and Android users are typically a little less likely to buy an app than Apple users are. But that's just something to think about. It kind of offsets this advantage up here, I would say, if you're looking at it from a financial point of view. And then over on iOS, some of the pros, okay, so this is the opposite of this down here. When you're writing for iOS, you're only writing for one phone. You're writing for the iPhone, which is really nice. That's kind of a lie. You're writing for, now we have like 6 or 10 different iPhones. that have been released. So you're writing for the most current iPhone, and probably you want to support the last 2 or 3 iPhones that have come out as well, just so the people that have slightly outdated phones aren't pissed off that your app doesn't work. And this is a good one. Basically, Apple users are more likely to pay for apps. Just the clientele is probably, since they bought an iPhone, which is typically more expensive, and since they have Apple Gear, which is typically more expensive, they're probably more likely to open up their wallet, which is good from a development point of view if you're trying to make money. And then some of the cons. So for us, it's a new language, it's a new development environment. You got to pay this fee, and you need a Mac. And I put kind of here because there are some workarounds, especially if you are into pirating software. Not that I necessarily condone that, but if that's your thing, you can make it work on a Windows machine or a Linux machine if you want. Also, there are some other solutions, like you can rent virtual Macs that run in the cloud, which is kind of slow, but it does work if you're trying to get it done, and it's cheaper than buying an actual Mac. And another con is that they've got these publishing reviews, which is not necessarily a bad thing, but it is something to consider. So that's kind of a side-by-side review. So the conclusion that I would draw from this is basically, if you're trying to learn mobile development, if it's something that's interesting to you, then just start out with Android. Because there's no pressure. You can learn for free. You can test it out really easily on your phone or your friend's phone. And it's just kind of like a friendlier setup. And then from there, it's actually really easy because a lot of the concepts are pretty similar in mobile development. So it's really easy to transfer your skills to iOS after that, I would say. So that's something to consider. Also, another thing I wanted to tell you guys is both Apple and Google, who runs Android, take 30% of anything you make on a mobile app. So if you're selling an app for a price, they take 30% of that price. If you are running ads on your app, they take 30% of that ad revenue, which is, I mean, it's unavoidable because both these guys do it, and they do provide you with a lot of services, so it's reasonable to some extent, but just know that before you get into it. If you're trying to price things out or whatever, just know that. Okay. So that's mobile development. But what if you have an idea that isn't specific to using a computer or using a smartphone? Like, what if you have an idea like this? You want to make a smart hammer, which keeps track of how many strikes it's made. And maybe it logs it to the internet and creates a graph or something. Maybe if you had a construction company, you would want to see how hard your workers were working or something like that. So that's the product that you maybe want to make. Maybe you want to make it so the curtains in your house automatically close when it gets too sunny. So these are embedded project ideas. So basically what that means is you are using physical things and maybe sensors and other hardware like that aren't specific to your average laptop or smartphone. And basically, if you want to do something like this, you need something like this. So this is called an Arduino. I actually have one here to show you guys if you want to see. So you can pass that around. So this is like well, I'll show you on the next page actually. So this is a low-cost microcontroller is what it's called. And basically that just means it's a simple computer. So this specific one that I'm passing around right now is called the Arduino Uno. It's the most popular model. I think it's like $30 or something like that. And to write code for the Arduino, you use a simple version of C/C++, which is actually really, really similar to what we've been doing in Java, and you'll have no problem picking it up because it's really simple code to write. And it's basically got digital, analog, and serial input-output, if that really means anything to you. But basically what that means is that you can interact with sensors or motors or LED lights or anything like that. You can control them and read data from them and basically use them in your projects. And also available for Android are these shields. which extend the abilities of the Android. So there's like Wi-Fi shields available, Bluetooth, touchscreen shields, all this stuff that basically allow your Arduino to do all these cool things. Like you can have it have a Wi-Fi connection, or Bluetooth, or touchscreen, or accelerometers, or whatever, basically whatever you want, there's something available. And if you can design the right system, basically the sky's the limit. I really, really, really love Arduino. I think it's really cool. It's got a really big community behind it, online community that offers help for free because people really love this stuff, and there's all sorts of cool things you can make. And I've got a few examples here just to get you excited. Let's see. Do I have to hook it over here? Maybe. So yeah, if you like building things with your hands, if you like kind of designing systems, or maybe you think that circuits are cool, or you just like the idea of creating one of these embedded systems, then pick up an Arduino and start playing around with it because it's really awesome. And let's see. Oh, here we go. Okay. It's a little bigger. Okay. So these are like projects that people have done. There's someone who made Christmas ornaments. Here's a sound alarm. This one I thought was cool. So someone basically used like an accelerometer type thing over here and an Arduino over here, and was able to track your sleeping patterns and graph them, which is pretty cool. And there's obviously some applications for that in a number of different ways. This is like a drawing machine. Here's a clock. Here's like a do-it-yourself game controller that someone made. Here's an MP3 player. This one's pretty cool too. So this one uses a camera to read an image and infer things about that image using the Arduino and a camera. Here's one, if you like Reddit, that tells you if you have a message. This is like a device that someone recreated that's actually in a popular video game if you ever played Fallout. Okay, this person used a Wii controller to steer a laser pointer. So you can see this is just kind of like some crazy ideas that people had the time and the passion to actually create. Here's an RC car. Here's a huge, humongous disco ball. This one's cool too. So this guy was able to use an Arduino and some other software to break into hotel rooms. So yeah, I guess he was able to gain access to 4 million different hotel rooms using just that Arduino and probably some magnetic writing type device up here. So that's pretty cool. There's all sorts of stuff you can do with LEDs, and this person made Tetris and put it in a pumpkin for Halloween. So this guy made a drink mixer, which automatically made different drinks, so if you're into that. And this guy created a lamp that changes properties based on different factors in the environment. So that's like kind of an overview of things that are possible and like cool ideas that people have had. And what Arduino is really good for is mocking stuff up. So if you have an idea that you want to eventually sell or bring to some sort of market, you can create your prototype with an Arduino, see what sort of functionality you need, and then you can send away for individual computer chips. There's different companies that do that, and then you can get even cheaper things that are smaller. But you need to start somewhere, so if you get an Arduino, you can see what you need to be able to do and what qualities your chip needs to have, and then you can go from there. So Arduino is really awesome, in conclusion. Let's get back to this. So if that interests you at all, pick up one of those and start messing around with it. Okay, and now I wanted to go into some other aspects of computer science that you can get into. So as we said in the beginning, we've been learning the basics of programming this summer, and once you get the basics down, there's tons of new things you can start doing. And here's an overview of some of them. So web development. Web development. So everyone knows what websites are. There's all different kinds of websites. There's really complex ones, really simple ones, really beautiful ones, really ugly ones, ones that allow you to play games, ones that just display text. So there's all different kinds of websites. But if you want to get into start making some of these websites for yourself or for clients, if you want to become a web developer, this is what you need to learn. So first step is to learn HTML, and that's Hypertext Markup Language. HTML is basically the bare bones of a website. So it gets your text and your pictures out there and readable by a browser. So like Google Chrome or Firefox or Internet Explorer. And HTML is actually not even a programming language, it's just a markup language. So it's pretty easy to learn. You can learn it in probably a day or two, or at least learn enough to start using it, and then you can learn as you go. But the idea there is that it's really simple. So that's the place you want to start, learning HTML. Then after that, you can learn CSS. CSS stands for Cascading Style Sheets, or Style Sheet. And it's actually another thing that's not a programming language. It's just basically an add-on to HTML. But what it does is allows you to stylize your web page or make it look really nice. So you can change, the type of font you use or the color of your font, or you can change how your pictures look, or you can add animations and all that kind of good stuff. CSS is actually really powerful, and it's another thing that's really pretty easy to learn. Again, in a day or two, you will be up and using CSS and creating web pages, which is cool. So after you've learned these two things, you'll have the ability to make websites that are really good looking and have tons of information. But if you want to allow your website to have kind of like more abilities, or like the ability to interact with a database or store info, or do calculations, like if you want to check and see if someone's filling out a form correctly, or if you want to do calculations on your page, you need to learn JavaScript, basically. And unfortunately, this name is kind of annoying. It doesn't have anything to do with Java. It's a completely different language. I don't know why they did that. It's really annoying because people get these two confused all the time. But JavaScript is a browser or client-side scripting language. So what that means is it's a language that you use to write scripts. Scripts are basically small little programs that run inside your browser. So inside Chrome, inside Firefox, whatever you use to browse the internet, the scripts that are written in JavaScript will run there, and basically it's pretty easy to learn. It's actually so it's got some of the similar concepts that we've been learning. There's variables, there's methods, there's kind of a class type deal going on, but it's really simple, and you can learn it not as easily as these two, but you can definitely learn it on your own, and we'll go over how to do that in a second. But the other thing you need to learn is PHP. PHP is a server-side scripting language, so that's probably kind of confusing to you. But basically what that means, so where JavaScript runs on your computer, the person who's browsing the internet, PHP runs on the server that is hosting a given web page. So basically the most common use of PHP is to enter data into a database or take data out of a database for the person who is browsing your web page. So if you're going to fill out a form and order something, PHP will take that information from the form, put it in a database, maybe create an order and send it off to a warehouse or something like that. But this is another language that is a scripting language. It's pretty easy to learn. It's actually really similar to JavaScript, but a little bit more complex than these first two. And if you want to learn these things, this is a really good spot. So let's just look at it really quick. Oh. What's that all about? One sec. Let's just do it up here. Okay, yeah, so this is the spot, w3schools.com. So if you want to learn HTML, I would do this right here, learn HTML5. Then it's got all sorts of stuff to learn over here on the side. You can just kind of march through it, go next chapter, next chapter, next chapter, read through everything, try some of the examples. And it's really nice. It's got a lot of information. It's presented in a good way. And if you're interested in web development, I would say this is the place to start. So they've got a tutorial on HTML. They've got a tutorial on CSS, on JavaScript, PHP, and all this other stuff too that you might want to learn down the line as a more advanced web developer. But it's good stuff. So check that out if you're interested in web design. Let's see. Okay. So that's web development, web design. Another aspect of computer science that you can get into are databases. So as you can probably guess, databases are an organized collection of data. The database system is a software system which creates a database for you and then allows you to interact with that database. And basically, typically, you can interact with your database with SQL, or SQL, which is a querying language. And also, whenever someone's trying to teach you something techie like this, or like what I've been doing this whole time, there's all these like buzzwords, like querying language and SQL and SQL and stuff that can be like making you confused because you don't know what they are exactly, but it doesn't necessarily mean it's complicated. Like SQL is actually pretty simple, but you do have to learn it. And basically databases are extremely useful. They are what allow us to link up like a website and a mobile app and a desktop app to the same thing. This is how you can have like a Gmail service or something on your phone, which is the same Gmail service on your desktop computer, which is the same Gmail service on your desktop app or whatever you want. So databases are really cool. They kind of allow us to link everything up. And making databases faster is a huge research area. Basically, most people who tell you that they are a grad student in computer science are doing something on databases. That's how important it is. And let's see. What else did I want to say? Yeah, okay. So some examples of database systems that you may have heard are MySQL, SQLite, Oracle is a database company that has their own system. And if you're interested in this, you can also learn that on w3schools.com. And if you ever want to get more into computer science, definitely take a database class at some point, because knowing about databases is really, really important. And it really makes you a better, more versatile computer scientist, I would say. Okay, so that's databases. Graphics. Graphics are awesome. Graphics are, in general terms, the rendering of a 2D or 3D space to your computer screen. And basically, it's if you like math, if you like geometry, and I don't think you guys, I don't know if all of you have been exposed to linear algebra yet, but these are the things that make graphics tick. This is the brains behind graphics right here. And graphics are really computationally heavy. So if you've noticed, graphics have probably been getting better and better and better and better if you've been paying attention. So like a video game that was made in 1997 is going to look much cruder than a video game made today. And this isn't necessarily because our algorithms and our software has gotten much better, but it's because our computers have been getting much faster. So it's almost like the speed of your computer is the bottleneck of how good our graphics can be. And also, additionally, we've also been getting more creative with how we do it. But this is one of those things that's kind of like driving the speed of computers faster and faster. And it's also, graphics are evolving really fast, as you've probably noticed. Graphics, even movies that are 3 or 4 years old now, that have computer graphics in them, look kind of weird now, because things are getting obsoleted by new techniques and faster computing, which is pretty cool. And because it's so computationally heavy, it requires that you be really clever in how you code things. So if that sounds cool to you, then maybe check out graphics. And the applications are pretty obvious. If you want to work on video games or be in show business or work on other visual media, graphics are everywhere. So if that interests you, then check it out. And here's like an example graphics project just so you can see what it's all about. Yeah, okay. So this was something written in C++. I don't know how well it'll... Yeah, okay, so you can see it pretty well. Basically, this is 500,000 particles being controlled by a program, being created and kept track of and told to do these fancy things, all with a program. The resolution's not so great, but it's all right. So if this looks cool to you, and you like math, and you like challenging programming problems, graphics is for you. I actually thought graphics was really cool, and I took it in school, and it's definitely a lot of work, but it's really rewarding because you get to see this nice visual final product, which is not always the case, but it's really cool. Okay, we're not going to watch all that. So that's graphics. Okay, and then we've got robotics, which is, a mix of engineering and computer science, as you could probably guess. And I'm not going to go too much into the details because it's pretty obvious what it is. It's creating and controlling robots. And there's tons of applications. So if you ever watched the show How It's Made on the Discovery Channel, they show how various products are made. And you can probably see that usually it's some crazy robotic machine that does most of the work. And the designing and creation of these machines is a discipline of robotics. Also, if you've ever been to Stop and Shop or CVS or any retail store really that's a big chain, you've probably seen self-checkout, right? Where you can check yourself out, and I'm sure this is just going to get more and more sophisticated where you end up probably just dumping all your products into a machine and then paying with your credit card. So this is another application of robotics and medicine. So robots that operate on people or help operate on people, or medicine that is able to drive itself to the correct spot in your body and do some operation or medication there. So all this stuff is coming or here already, and more. So robotics is a really exciting field if it seems cool to you, and it's really math and physics heavy. If you like those things, maybe robotics is for you. And here's a quick example of an awesome robotics project. Again, we're not going to watch all this, but it is really cool. So.
So what does it mean for a machine to be athletic? We will demonstrate the concept of machine athleticism and our research to achieve it with the help of these flying machines called quadrocopters, or quads for short. Quads have been around for a long time. The reason that they're so popular these days is because they're mechanically simple. By controlling the speeds of these four propellers, these machines can roll, pitch, yaw, and accelerate along their common orientation. On board are also a battery, a computer, various sensors, and wireless radios. Quads are extremely agile, but this agility comes at a cost. They are inherently unstable, and they need some form of automatic feedback control in order to be able to fly. So, how did it just do that? Cameras on the ceiling and a laptop serve as an indoor global positioning system. It's used to locate objects in the space that have these reflective markers on them. This data is then sent to another laptop that is running estimation and control algorithms, which in turn sends commands to the quad, which is also running estimation and control algorithms. The bulk of our research is algorithms. It's the magic that brings these machines to life. So how does one design the algorithms that create a machine athlete? We use something broadly called model-based design. We first capture the physics with a mathematical model of how the machines behave. We then use a branch of mathematics called control theory to analyze these models and also to synthesize algorithms for controlling them. For example, that's how we can make the quad hover. We first capture the dynamics with a set of differential equations. We then manipulate these equations with the help of control theory to create algorithms that stabilize the quad. Let me demonstrate the strength of this approach. Suppose that we want this quad to not only hover, but to also balance this pole. With a little bit of practice, it's pretty straightforward for a human being to do this, although we do have the advantage of having 2 feet on the ground and the use of our very versatile hands. It becomes a little bit more difficult when I only have 1 foot on the ground and when I don't use my hands. Notice how this pole has a reflective marker on top, which means that it can be located in the space. You can notice that this quad is making fine adjustment.
There's one other part that I want to show you because I think it's the coolest part. But he goes on to show a bunch of amazing feats.
The vaulter, it is only through repeated practice that the maneuver can be learned and executed to the highest standard. Striking a moving ball.
Oh no, this is the good part. All right. Oh well. You have to watch it yourself, but basically.
Striking a moving ball is a necessary skill in many sports. How do we make a machine do what an athlete does seemingly without effort?
Anyway, I thought that was really cool, and really impressive. So if you think something like that's really cool, maybe robotics is for you. Pretty amazing. Okay. Let's see. Yeah, give ourselves some time. And then there's tons. Those are just a few topics that I thought could be cool to you guys. And here are a few more, just so you guys know what's out there. Computational biology. So this is analyzing sets of biological data, such as DNA, and trying to infer some conclusions from that, which is really cool if you like biology and you want to apply some programming to it. This is what you need to do, computational biology. Systems is another part of computer science. Systems is kind of like what's going on in the background on your computer. So it's like your operating systems, or your programming languages, or anything that you don't actually see working. So if you like doing all the work and get none of the glory, then work on systems, because that's exactly what happens. Networks, so understanding internet protocols or data network protocols or any network, you can study networks. It's pretty cool. Computer vision. This is a really important one now, this is where a lot of the growth in computer science is headed. This is allowing computers to understand images. So this is something that humans do really, 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 really well compared to computers. We're able to look around a room and immediately identify objects, identify faces, see where things are moving, where they're headed, what's happening in a given scene. Computers, not so much at this point. It's really hard for computers to maybe use a camera, the sensor of a camera, get that data, and then understand what's going on in the scene. Just with how digital computers work, this tends to be really computationally heavy, and it ends up being pretty error prone. But this is a subject that we're working to get better on. And if you think that sounds cool, then you should get involved in it. And one of the computer vision problems that I've always wanted to be realized is the traffic light problem. So right now we use weight sensors to trigger our traffic lights, which is a reasonable fix, but not great. Often you'll find yourself driving up to an intersection that has a red light, even though there's no one coming the other way. And you end up wasting fuel and time sitting at that traffic light. And if you multiply that by the millions of people driving cars, that's a lot of wasted time and money. So if we could have a camera that basically was able to realize what was going on at the intersection and cleverly change the light accordingly, we would be much better off. But we're not there yet. So someone's got to figure it out. Maybe it can be you. So another topic is machine learning. So this is giving the computers the ability to learn from a set of data. So this is kind of like the next tier. So we've been able to program computers to do tasks for us, and now we basically want to be able to program computers to learn to do tasks for us. So this is like the next step. It's pretty cool. It's really, really challenging and really math heavy, but it's definitely an interesting aspect of computer science. Algorithms and data structures. So this is something that every computer scientist will deal with at some point, but some people really like it and focus on it. And this is creating clever solutions to problems that work quickly and elegantly, and maybe that store data intuitively and allow you to access that data quickly. An example of this, maybe when we were writing that algorithm which created prime numbers back in class a few weeks ago. Remember when we were saying there's more clever ways to create the prime numbers? Well, there's more clever ways to do most things than what you originally come up with. So if you like improving upon yourself and getting faster and better, this is what you want to do. Another thing, CS Econ. So this is kind of like programming with more financial outlook. So if you like finance or the trading world, then maybe you can pursue something like CS Econ. And actually, one of my good friends from college is working at a job right now where he does just this. He writes programs which basically buy and sell different energies like oil or natural gas or whatever, and buys and sells that depending on what the computer program determines the actual value of these things are, and then hopefully makes tons and tons of money, which is something that will probably happen if you get into this field. But it's maybe not necessarily the most satisfying field if you aren't into that thing. So don't pursue it unless you think it's interesting. And here's something that I kind of wish I did more. CS neuroscience. So basically getting the computer to understand the brain more and getting the brain to understand the computer more. Yeah. Yeah, that's me. Oh, okay. It's all right, thank you. Yeah, I'll jump in if I have to. Thanks. Okay. All right, yeah, so that's a really cool field. If that sounds interesting to you, then pursue that. And so that's it. That's our lessons this summer. That's the end. It's kind of sad, but it's good. So what I want to say to you guys is if you enjoyed any part of what we did this summer, if you enjoyed programming at all, if you got any satisfaction from seeing your code work in when you started running your program, or if you found anything that we talked about today interesting, or really if you thought anything about what we did was cool, then I urge you to continue pursuing this. Take another class. Code more on your own. Keep at it. Don't give it up, because this is something really, really valuable to learn. And it really will make you a more interesting and powerful person, and it'll give you tons of opportunities that I think you will appreciate. Change the world. This is how you change the world now. This is how it's done. So if you thought anything was cool, then give it another shot. Give it another class. Code more, and if you ever want to, if you ever need advice on a class to take, or advice on a project that you're trying, feel free to email me or call me or whatever, and I'll do what I can to help. And other than that, thanks a lot. Thanks for coming out every night this summer and coming to lab and trying your hardest and trying to learn, because I really appreciate it. And I hope you learned something, and I hope you had some fun. And I know I did. And other than that, see you on Wednesday for our last lab. So thanks, guys.